going to talk you through kind of a strategy that I use when I'm troubleshooting models. But the first thing I want to talk about is I think there's like a key mindset that you need to have when you're actually going through this process. Any ideas what this might be? Yeah.
Be very suspicious.
Be very suspicious. I like that. That's exactly right. It's pessimism. Yeah. So, I think you need to be pessimistic because since it's so hard to disambiguate errors, you really need to be careful that you're very critically looking at all the choices that you make when you're designing your model in your code base. And so the implication of that is that really the best strategy is to start as simple as possible and then very gradually ramp up complexity. And we'll talk more about how to do that. And so the strategy that we're going to talk through today looks something like this. You start very simple, make the simplest possible choices, then you implement and debug those choices and evaluate their performance. Once you've evaluated their performance, you reach a decision point. And from there, you can either decide to improve your model or improve your data set, or you can just tune hyperparameters. And then eventually, once you go through this loop enough times, hopefully you get to the point where you finally meet your requirements and you're done. So starting simple, this usually means choosing the simplest possible version of your model and data set that you can get your hands on. And so in our labs, for example, we've instead of starting with a very complex real data set and an LSTM with CTC loss, like a complicated model, instead we started with a just very simple fully connected network or Linnet on EMNIST. So simplest possible model, simplest possible data. Once you've chosen those, then you implement your model and debug it. So make sure that you can overfit a single batch and maybe reproduce a known result. And then you evaluate the model. And to evaluate the model, you apply the bias variance trade-off, and you decide what to do next. Then you tune your hyperparameters. And finally, you prioritize improvements to your model and data. So maybe you move towards something that's more state-of-the-art.